My dear students, today we are going to discuss about the eigenvalues and eigenvectors, that is how to find out. I'm going to start with the 2 by 2 matrix. So let me consider the matrix A equal to 1 minus 2 minus 5 4. So the procedure for finding that characteristic equation is determinant A minus lambda is equal to 0. So I applied that A minus lambda I. So in the diagonal, leading diagonal, we have to subtract lambda, then it is equal to 0. So we need to expand this determinant. For that I am going to teach you how to find out that characteristic equation by using shortcut method. And for 2 by 2 matrix I have given that with the matrix notation A11 minus lambda, A12, A21, A22 minus lambda is equal to 0. So because of expanding this 2 by 2 matrix, you will get a quadratic equation in lambda. So it is equal to lambda square minus s1 lambda plus s2. And I have considered here because the quadratic equation because of 2 by 2 matrix. So by expanding 2 by 2 determinant, we will get automatically the quadratic equation. So your s1 is nothing but sum of the leading diagonal elements. So I can write this is nothing but just you have to add your leading diagonal elements. Leading diagonal elements, and your S2 is nothing but a determinant value. Now you see that by using the given matrix, I started to find out your S1 is equal to 1 plus 4, which is equal to 5, and S2 is nothing but a determinant value. So determinant 1 minus 2 minus 5, 4, which is equal to minus 6. Just I substituted that value in the characteristic equation, which is lambda square minus 5 lambda minus 6 is equal to 0. So by solving this equation, you will get lambda is equal to minus 1 6, because solving this equation you have already studied in your lower standard by factorization method. So the eigenvalues are minus 1 and 6. Now similarly, we are going to have a 3 by 3 matrix. So in the case of 3 by 3 matrix, just for example, I have taken one matrix which is completely a non-symmetric square matrix of order 3 by 3. And we are going to find out the characteristic equation of this given matrix. So the matrix characteristic equation is given as determinant A minus lambda is equal to 0. And I made a determinant with the leading diagonal elements. I subtracted lambda. Then I need to expand this value. So this determinant I need to expand it. So just I am showing how to expand the determinant by using the synthetic division method. Using the shortcut method. So the shortcut method is, just I have written along the diagonal I subtracted lambda in 3 by 3 matrix. That is A11 minus lambda, A22 minus lambda, A33 minus lambda along the diagonal. The remaining elements I have written as it is. So which is equal to 0 by characteristic equation. And here I have started with the cubic equation because it is a 3 by 3 matrix. So by expanding this determinant, we'll get only a cubic equation. So it is lambda cube minus s1 into lambda square plus s2 into lambda minus s3. And what is s1, s2, s3? I have given the explanation. So our s1 is nothing but sum of the leading diagonal elements, which is a11 plus a22 plus a33. And your S2 is nothing but sum of the minors of the leading diagonal elements. And so which is I have given explicitly or how the elements will be. So how to find out these minors you have already studied in your lower standard in 11th and 12th standard. But besides that, I will explain you the minor leading diagonal elements are A11, A22 and A33. Now we are going to find out minor of this A11. So automatically you have to delete your column and row. The respective remaining elements only you have to make a determinant without sign. So it is A22, A23, A32, A33. Similarly, this is and similarly for the second leading diagonal element, you have to delete the respective column and row. And the remaining elements are A11, A13, A31 and A33. So this will give you the second leading element minor, leading diagonal element minor. And similarly, we have to go for the third one. So for the third element, you have to delete the respective column and row and find out the remaining elements. So it is A11, A12 A21, A22. Then after that, you have to add all those elements so that will give you totally S2 value. And your S3 is automatically, it is equal to the determinant value as that of in the previous one we have seen in 2 by 2 matrix. So here your S3 is nothing but determinant value of A. Okay. So now I am going to apply in the problem because the already problem is given. So we started with the problem, start to find out our S1. So our S1 is, you see that sum of the leading diagonal elements, that is 2 plus 1 plus 1, 1 plus minus 1. So 2 plus 1 plus minus 1, it gives you 1 and minus 1 get cancelled. You will get automatically 2 is the answer. Similarly, S2 is nothing but sum of the minors. So for that, we have already taken for this matrix, you see that it is a given matrix. So your first minor is automatically by taking the leading diagonal element as 2 and deleting this row and column 1, 1, 3 minus 1. So that only I have taken here 1, 1, 3 minus 1. Okay. Similarly, the second element, leading diagonal element minor is, you have to delete row and column, take the remaining, that is 2, 3, 1 minus 1. So that only I have written it as a second one, that is a 2, 3, 1 minus 1. Next one, similarly we have to take the third leading diagonal element minor. So this is your third leading diagonal element minor. So by deleting row and column, the remaining is 2 minus 2, 1, 1. That only I have given here as 2 minus 2, 1, 1. Okay. So by adding all those elements, so what will we get? All those elements. And adding all these three elements, we'll get minus 1, minus 3, minus 4, minus 2, minus 3, minus 5, 2, minus of minus 2 plus 2, 4. So 4 and minus 4 get cancelled. So 4 and minus 4 get cancelled. You will get the answer as minus 5. And determinant value, you know very well that how to find out the determinant value. So the determinant value of A is equal to determinant 2 minus 2, 3, 1, 1, 1, 1, 3 minus 1. So it is 2 into minus 1 minus 3. So because same we add the minus. So it will give you minus 6. So the characteristic equation is lambda cube minus 2 lambda square minus 5 lambda plus 6 equal to 0, because I have given already it is alternatively plus and minus. So your lambda cube coefficient is always positive, lambda square coefficient is negative, lambda coefficient is positive, again constant term is negative. So based on S1, if it is any minus value, then it is minus of minus, it will become plus. So we have to be very careful in writing the final characteristic equation. So I have written the final characteristic equation. So this is a lambda cube minus 2 lambda square minus 5 lambda plus 6 is equal to 0. It gives you the characteristic equation. Okay. So now to find the synthetic division, by synthetic division, the roots of this equation or the factors of this equation, cubic equation, I applied synthetic division method. How to apply synthetic division method is very simple. You start with 1 minus 1, then go for 2 minus 2, 3 minus 3. So by trial and error among the 6, definitely one root will satisfy this given equation. So always you start with plus 1 and minus 1 and plus 2 and minus 2, then plus 3 and minus 3. Among the 6, definitely one root will satisfy. Then by using that root, you reduce the given equation and make the quadratic equation. Then you solve the quadratic, and another way is continuously you can apply synthetic division. Okay. So now I am going to apply synthetic division by taking 1 as the root. So 1, write coefficient of all the cubic equation, 1 minus 2 minus 5, 6. Then start with 0. So 1 plus 0, 1. Then 1 into 1, 1. Minus 1, minus 2, 1. It gives you minus 1. So 1 into minus 1, minus 1. It is minus 6. Then 1 into minus 6 is minus 6. 6 minus 6, it becomes 0. So either you can make this, you can stop up to this, the synthetic division. And you can write directly from this the quadratic equation. How to write the quadratic equation is lambda square minus lambda minus 6 is equal to 0. You will get one quadratic equation. Or you can apply here itself the synthetic division. So I applied 2 minus 2, it's not satisfying. Minus 1 is also not satisfying. How to find out whether the synthetic division is we are going in a correct way is just it should be ended with always 0. The 0 is very important. If it is ended with some other element, it shows that this root is not satisfying this equation, or this is not a correct factor for this equation. So automatically you have to go for the next root. So like that I tried minus 1, which is not satisfying, and I tried 2 and minus 2, which is not satisfying. So I tried now the 3. So taking 1, 0, again always you have to put 0 here. So it's 1 plus 0, 1, 3 into 1, 3, and 3 minus 1, it becomes 2, 2, 3 into 2, 6. So 6 minus 6, it becomes 0. Okay. And last one is this, it gives automatically, it is lambda minus 2. This is the reduced equation, linear equation. So that only I have written. So lambda minus 2 equal to, lambda plus 2, because it is plus 2 is there. So lambda plus 2 equal to 0. So lambda equal to minus 2. So this is the way to find out that roots of this equation. So now we found the roots as lambda is equal to 1, lambda is equal to 3, and lambda plus 2 equal to 0. So lambda equal to minus 2. So your roots are lambda 1, I have taken 1 in alphabetic or numerically without considering the sign. I am writing that eigenvalues. Okay, so lambda 1 equal to 1, lambda 2 equal to minus 2, and lambda 3 equal to 3. Now we are going to find out the eigenvector. So for finding eigenvector, you take the first value of lambda 1 equal to 1 and write the equation as a minus lambda 1 into I into x1 equal to 0, because this is the normal general equation for finding the eigenvector. And here the eigenvector, your capital X will be considered as always a column vector, which is x1, x2 and x3. So the elements of eigenvectors are x1, x2 and x3. So you have to take x2 and you have to take x3. So this is the eigenvector. Normally we will consider always your eigenvector as a column vector. It never be a row vector. It was always a column vector. So now based on that, I have written now for the first eigenvalue lambda 1 equal to 1. I subtracted along the leading diagonal that 1. Then the remaining element it keeps as it is into x1, x2, x3 is equal to 0. So now your first eigenvector we are going to find out. So by expanding this, you will get a system. It's a system of linear equation, and where it is a homogeneous equation, that is the right side is 0. So by solving this equation, by solving this homogeneous system, our solution is always either an infinite number of solution or it is a trivial solution. So trivial solution, if I am taking eigenvector, never be a zero vector. So please remember that always eigenvector, whenever you are writing that, it is always a no infinite number of solution only exists for the eigenvector. So I can write always 0, 0, 0 as a eigenvector. This is not correct. So you should not write it as a zero vector as a eigenvector. Okay. So now based on that, we are going to solve this equation. We are going to solve the system by taking any two equations, because it's not necessary you have to go for all the three equations you need to consider, because either we can go by Cramer's rule or by any other method to solve this equation, but here you need to consider only any two equations among this non-repeated equations, and then you you make use of that cross rule multiplication method and find the eigenvector. So I consider here among these three, even though all the three equations are distinct, I consider the first and second equation. So based on first and second equations, I have written that coefficients. In what way you have to write the coefficient is, you should consider always when because we need to find out our x1 value first. So automatically we need x2 coefficient and x3 coefficient. So on the top of that x2 and x3 coefficient, you write that value which we are going to consider as x1. Similarly, x3 coefficient, then automatically x1 coefficient. This is again where you started with the x2 coefficient. Now in between this, you have tried this is x2, and in between this you have tried it as x3. And based on that, by cross multiplying it, I have written that cross multiplication. So your x1 divided by minus 2 minus 3, 0. So your multiplication always should be this side first, then next one is that side. So it is x2 divided by 3 minus 1, x3 divided by 0 plus 2 is equal to k. So k is an arbitrary value. You can give any value for k, convenient value, and there is no restriction for assuming the k value also. To make your eigenvector is numerically very small value, you can assume any value of k. So based on that, I have given that value is equal to arbitrary value, constant value k. Now by reducing it, you will get x1 by minus 2, x2 by 2, which is equal to x3 by 2, which is equal to k, and it is equal to minus 2k, 2k and 2k. And by reducing, by taking k is equal to 1 by 2, the minimum vector, minimum constant value, we'll get the eigenvector minimum value as minus 1, 1 and 1. So this is our required suitable value of eigenvector, that is x1 is equal to minus 1, 1 and 1. Okay, so now we are going to see the next two vectors for the remaining two eigenvalues. So to find the eigenvector of x2 for lambda 2 equal to minus 2, we have a minus lambda 2 into I into x2 is equal to 0. So in this case, our lambda value is equal to minus 2. So automatically this characteristic equation, finding eigenvector equation, it will become a plus 2i into x2 is equal to 0, because already your equation is, it is a minus of minus 2, it will become plus 2i into x2 is equal to 0. Now you substitute this matrix, and it's 2 plus 2 minus 2 3 1 1 plus 2 1 1 3 minus 1 plus 2 into x1 x2 x3 is equal to 0 0 0. Okay, so now you expand this equation, so it becomes 4x1 minus 2x2 plus 3x3 is equal to 0. And x1 plus minus plus 3x2 plus x3 is equal to 0, and the last equation is x1 plus 3x2 plus x3 is equal to 0. So by using all these three equations, again this is a linear system, and where it is a homogeneous equation because the right side part is 0 0 0, and by solving this equation, again this the same reason is there, that is you will get it as this is here also either the trivial solution or you will get an infinite number of solution. Okay, so we need to consider only the infinite number, but you see that here these two equations are same equations. So by solving these two equations, it leads to trivial solution only. So on the basis of that, you should not write the trivial solution as the solution of this equation. That is completely wrong. We can't write 0 vector as the eigenvector for the given problem. Okay, so that's why we have to consider either first equation with the second or first equation with both are same only. So you should not make use of these two equations for finding the eigenvector. Obviously the vector value will be 0 vector only, but eigenvector never be a 0 vector. So you need not consider if the two equations are the same. Okay, so start to apply that. Now it is x1 divided by minus 2 minus 9, then x3 which is equal to x2 divided by 3 minus 4. So it is here, it shows that as usual this is your x1 and this is your x2. And this is your x3. Okay, so x3 divided by 4 into 3 12 minus of minus 2 plus 2. So by taking that value is equal to k, we will get minus 11k, minus 1k and 14k. In this case actually we can't take k as a arbitrary any value to simplify this, because if all the if by substituting k is equal to a suitable value, if all the 3 is able to reduce it numerically very less value, then only you have to take common value of k, suitable value of k. But here k we can't, which is 11 is not divisible, it is all our prime numbers. So 14 is divisible, but we can't give the suitable value to make that 11 as reducible. So that's why we can't take it as k value as an arbitrary value or any choice. So I have taken k is equal to 1 only. So where x2 is equal to, now it is minus 11, minus 1 and 14. Okay. So this is a different type of finding the eigenvector. So make sure about your type of equations in a linear system of homogeneous system. If any two equations are same, please don't consider to find the eigenvector by making use of the same two equations. Because by solving the equations by cross multiplication method, you will get 0, 0, 0 as an eigenvector. 0 vector never be an eigenvector. We can't write 0 vector as an eigenvector. So you don't consider that. That's why I considered either first with the third equation or first with the second equation. Okay. Now for the third eigenvector and for the third eigenvalue, lambda 3 is equal to 2. We have to take the same way. So I have written a minus lambda 3 into I into x3 is equal to 0. So it is a minus 3i into x3 is equal to 0. And I have substituted all the matrix elements into x1, x2, x3, which is equal to 0, 0, 0. Now you see that these three equations are completely different, and you can take any two combination. As usual, I have taken first and second. You can take first and third also. So nothing wrong in that one. Then second and third also you can consider. Any two combinations you can take, because all the three equations are distinct and no two equations are same. So by solving this equation, by taking first and second, I have started my writing the coefficient. So start to write always the coefficient as minus 2, minus 2, minus 2. Okay. Then we have 3 and 1. Then we have 1 and minus 1. Then minus 1 and 1. Then minus 2 and minus 2. So as usual, this value it gives you x1. And this middle one, it gives you x2. And this one, it gives you x3. So it is x1 divided by minus 2, minus of minus plus 6, x2 divided by 3 plus 1, and x3 divided by 2 plus 2, it gives you k, which is equal to a constant c, arbitrary constant. So it is x1 by 4, which is equal to x2 by 4, which is equal to x3 by 4, which is equal to k. It gives you x3 is equal to 1, 1, 1. Okay. So therefore your x3 is equal to 4k, 4k and 4k. So by giving a common value, because all the three are divisible by the same number, so I am going to give the arbitrary value of k is equal to 1 by 4. So it's 4 into 1 by 4 gives you 1. So all the elements are same, all the vector elements are same. So you got it as x3 is equal to 1, 1, 1. So therefore for the third eigenvalue, the third eigenvector is lambda. For lambda, third eigenvector is 1, 1, 1. So therefore our eigenvectors are here lambda 1, for lambda 1 equal to 1. For lambda 1 equal to 1, the vector is minus 1, 1, 1. And for lambda 2 equal to minus 2, your vector is x2 is equal to minus 11, minus 1 and 14. And for lambda 3 equal to 3, your vector is x3 is equal to 1, 1, 1.